13.6 is about conditional probability formulas. We talked about this yesterday a little bit in 13.5, so let's talk a little bit more about this. For any two events A and B, the probability of B occurring given the event A has occurred is the probability of B given A. That's how you write it. That little line between means given equals the probability of A and B divided by the probability of A, where probability of A cannot equal 0. It's just this thing so you're not dividing by 0. Again, I look at like that as a division sign. It's the probability of both of them, A and B, divided by the probability of A. So when we look at problem 1, they talk about a pharmaceutical testing and a study designed to test the effectiveness of a new drug. Half of the volunteers received a drug, the other half of the volunteers received a placebo, which is a tablet or pill containing no medicine. The probability of a volunteer receiving the drug and getting well was 45%. What is the probability of someone getting well given, that's the key word, that he receives the drug? So probability, okay, that someone is getting well given they got the drug. Okay, so what's the probability of both of them? It says the probability of a volunteer receiving the drug and getting well is 45%. So 0.45 is both of them. And then what was the probability of drug? Again, I look at this as like a division sign. The probability of both divided by the probability of getting the drug. And the probability in this case was 0.5. So 0.45 divided by 0.5 is just 0.9, or 90% is your probability. Okay, let's look at another problem. In a survey of pet owners, 45% own a dog, 27% own a cat, and 12% own both a dog and a cat. Now that's going to ask two questions. What's the conditional probability that a dog owner owns a cat? And what's the conditional probability that a cat owner owns a dog? They kind of sound like the same question, but let's take a look at it. The probability that a dog owner owns a cat. So what are you looking for? You're given that it's a dog owner. You want to know what's the probability that they own a cat. Okay, the second one, you're given that it's a cat owner. You want to know what's the probability that they have a dog. Okay. So again, we're finding the cat given dog. So what's the probability of both? So 12% own both. So 0.12 is going to go on top. Okay, now we again going to divide by the percent of dog owners. So that's 0.45. Okay, so that's going to be, just plug in your calculator, 0.267 or 26.7%. Now it's the same thing. It's still the probability of both, which still remains the same, 0.12, but now you're going to divide by the probability of a cat owner. If I look up top, 0.27 own a cat. Okay, so 0.12 divided by 0.27 is 0.444 or 44.4%. Okay, problem 3 talks about using a tree diagram. Okay, and it's a little bit hard sometimes to tell when you want to use tree diagrams and when you don't. But when they give you something, especially when they're comparing two things, in this day 70% of freshmen attended public schools, and then they're going to use freshmen of other schools. So let's start by talking about, we got public, we got other. Okay, 0.7 was public, so that means 0.3 has got to be other. We've got graduated, we got not graduated. It says 60% of freshmen who attended public schools graduated. So 0.6 graduated, which means 0.4 didn't. What about with other? Well, it says 80% of other graduated and not graduated. So 0.8 graduated, which means 0.2 other didn't graduate. So it's easier to just go ahead and find the probabilities of all of them and then go ahead and answer your question, especially make a tree diagram. So 0.7 times 0.6 is going to be 0.42. 0.7 times 0.4 is going to be 0.28. 0.3 times 0.8 is 0.24. And 0.3 times 0.2 is going to be 0.06. Okay? So those are all my probabilities across. What is it asking, if I can talk? What percent of freshmen graduate within 5 years? So what graduated? 0.42 and 0.24. So I'm going to take 0.42 plus 0.24, and that's going to give me 0.66. So 66% graduated within 5 years.